Had a question about problem 2959. So there's a switch, and initially the switch connects the battery with our capacitor. The battery has a potential of 100 volts, and the capacitor is 15 microfarads. So this capacitor charges up to have a charge. So this is our sort of total charge of 1500 microcoulombs, and it charges up to a total voltage of 100 volts. And then the switch then connects our capacitor, 15 microfarads, to two other capacitors. And so the 15 microfarad is essentially, so it's charged up. It's essentially like a battery now going to be charging up these two other capacitors, and these are 20 and 30. And so one thing that you can do here is think about these two guys as being two capacitors in series, and so use our equation here to figure that out. And if you do that, you can break this down to a system like so. Again, this is the 15 microfarads, and then this is 12. If we make the equivalent capacitance of those two, it's 12. And so what's tricky here is that, so the 15 microfarad capacitor, we got to realize what stays the same, what's going to change. Well, this guy is charged up. It's charged up with 1500 microcoulombs and 100 volts. But as it loses charge, it's going to lose potential. So we don't know what the final potential is going to be. But we do know that the potential final of the 15 has to be the potential difference of the 12. And so from our equations of capacitors, we know that this has to be true here. All right, so they have to have the same potential difference. So here, if whatever increase of potential I have, this has to be decreased by the same, so that I'm back to the same point by Kirchhoff's loop law. The other thing is that the charge has to add up to be the charge total, which is 1500 microcoulombs. So here I have two equations and two unknowns, and I can go through and solve for this basically by plugging one into the other. And so when I did this, my charge came out to be something like this, 833 microcoulombs and 667 microcoulombs. So again, this adds up to be about the 1500 microcoulombs. And so that's the charge on this guy and the charge on this guy. And I think then the problem wants you to find the potential differences by unfolding these two guys here, but realize that both of these guys have to have that same charge of 67 microcoulombs, and then this one will have the 833 microcoulombs. And so since you know the charge and the capacitance, you can find the voltage as a Q divided by C. All right, hope that helps.